How are we feeling? Are we on number 2? Are most people on number 2? No, that's next. It's G103. Oh. So who's feeling really confident in number 1? Ty? Going to report good? Remember, you're the teacher. You have to tell us what's the first thing you think about, the steps, be very meticulous in your thought process.
Alright, so first, we're gonna what is it called? Yeah, reciprocal.
Well, I'm going to correct you here. So right now, what you're doing is you're dividing by the rational coefficient, right? Which is 2 over 3. The rational coefficient is any number that can be made into a fraction. Okay? The reciprocal comes in. So there's another operation here that you could do that's equivalent to dividing by the rational coefficient tied to the variable. That would be multiplying by the reciprocal. So what would be the reciprocal for 2 over 3?
3 over 2.
3 over 2, exactly. So you could do it this way, which is completely correct, or you could multiply by the reciprocal. Doesn't matter. But keep moving.
Then
So what is it that we have in mind right now? Like what's the reason behind you doing this on this side, doing that on this side? Right?
I guess what goes around comes around.
What goes around comes back around, that's partially true, but even before that, I should have asked you this question a bit earlier. So even before that, what's the first thing that we have in mind when we look at this linear equation? We see a variable, right?
Mm-hmm.
What do we want to do to that variable?
Isolate it.
We want to isolate it, right? So we want to isolate it to one side of the equation. Is that done here beforehand?
No.
Yes, it actually is. So 2 over 3y equals 14. There's only one y, right? There's nothing else like being added or subtracted. However, it's not as lonely as we want it to be. So imagine y is just somebody or something you really don't like. I don't know. You want to make it as lonely as possible. So that's exactly why you're dividing by 2 over 3, right? To make it as lonely as possible. You want to leave it on an island. So, continue.
Alright, so now you're gonna do 14 times 3 and 2. And it's an imaginary 1 right here. So 2 times 1, 14 times 3. 14 times 3 is 42.
Okay.
2 times 1, 2. We can simplify this.
So y is equal to
21.
21. Did everybody get that? Right, you see what I'm saying here? So you just missed the divided by 2, but very well done. Well done, Jakai. Round of applause. Anybody want to do number 2? You got it? Come on. You got it? Let's create some space. Teacher? So again, what's the first question I'm going to ask you?
To isolate for okay. So this is outside of parentheses, we're going to distribute all to x, negative 4 to negative 7. Negative 4 times.
You can just write it up here.
Okay, negative 4 times x.
I'll just start right there.
Negative 4 times x. Okay. Yeah, we're gonna write that 8 equals. 8 equals. Negative 4 times x is negative 4x. Negative 4 times negative 2 is 2 negative is going to equal positive 6 plus 8.
So does everybody see that? What she did there?
Okay, so we're going to subtract from both sides. We're going to subtract 8 from both sides. Cancel this out. 8 minus, wait, 8 minus 0 equals 2. And divide negative 4 equals to isolate.
So she's isolating the variable x, just making it as lonely as it possibly can be. So actually this is not undefined. Well done. You got the answer right though. So very good job. So 0 over 4 is just 0. When something is divided by 0. So imagine if I had, let's say the number ended up being, let's say 4 over 0. That's an undefined number. Why? Right? Does anybody want to take a shot at it? Why? Right?
Because it doesn't equal to anything else.
Exactly. So 0 is nothing, right? It's an absence of something. So how can you divide something that isn't there? That's a whole philosophical debate. We'll get into that during lunch or something if you ever want to. But not right now. But yeah, so very good job. That is correct. So I know number 3 is kind of difficult, and I made it difficult on purpose. I first want to see if anybody feels particularly confident, ready to come up and do number 3. Isaiah? How you feeling? No? Okay, well, that's fine. I made it difficult with the intention, in like this scenario, I would just do it and I would go very slowly through it, just so we could all have a very good last understanding of how to solve these types of equations. So, when you guys see this, what's the first thing you think? You think parentheses, right? You probably see a bunch of fractions and parentheses and you get kind of intimidated. One thing I really want you guys to get from this class is to not be intimidated by fractions, by parentheses, by decimals, by weird looking numbers. That's why when I give you guys some problems and you guys are like, oh, why is there a decimal, why is there a fraction? It's not pretty, or it's not a whole number. That's the exact reason. So when I was growing up, I was very intimidated, like very easily by numbers. That's not something I want you guys to have, so don't be intimidated. So, pen this, right? I see the variable, x over 3. It's inside the parentheses on this side. I see this over here. This parentheses is basically just telling me that this is 15 times 3.
Yeah.
Everybody know that? Everybody understand that?
Yeah.
So what's 15 times 3 really?
45.
45. Okay, so that side of the equation, I could just kind of leave it alone right now. See these parentheses, right? I see that there's something tied to these parentheses outside. 5, right? We're going to do what Brianna did right here. We're going to distribute, okay? So, 5 times x over 3, 5 times 3, okay? 5 times x over 3 is what, Isaiah?
5x over 3.
Yes, sir. Okay, 5 times 3 is what, Alessandro?
15.
15. Okay? So now, when you look at this, from all these parentheses, from all the weird fractions, everything, how does this look now? Looks a lot better, right? Something that we've seen, something very comfortable to the eye. Alright? So now what's the next thing that we should have in mind? Is that?
To still isolate the x.
So we want to isolate x to one side of the equation again. So what do we have to do that? We have to subtract 15 from both sides. So 45 minus 15 is?
30.
Okay. So now we've isolated the variable to one side, right? Mariana, Chanel, is x as lonely as it could possibly be? No, right? What do we have to do?
You have to put 3 over 5 there,
Just put it, just 3 over 5?
and then you put it on the other side.
So what am I doing with this 3 over 5?
You're isolating x by crossing it out, and then putting it on that side.
Yeah, so I'm multiplying the 3 over 5, yeah, right? By this is the reciprocal of 5 over 3.
Yeah.
And why am I doing it to both sides?
Because it goes around.
Goes around, okay? These things cancel, right? So I'm left with just x here, okay? So 30 times 3 is 90,
I know that.
right? X is equal to 90 over 5. Can anyone do that math?
That equals 18.
18, very well done. Okay? We all see that? Do we have any lingering questions? Are there any concerns? Do we think that we need a little bit more practice, or do we want to move on and maybe look at some word problems? How are we feeling? We feeling confident? Yeah. What's your grade? A.
A.
Yana?
You're
Yeah.
Oh, A.
A. Dubai?
A.
Isaiah?
A minus.
Okay, so how do we get you to an A? That's the question. Alessandro? A. Okay. So you said A minus for a reason. Why did you say A minus? Okay. So I think we just need a little bit more practice. So let's do this word problem right here. Okay. So 7/9 of the weight of food donated. So I'm sorry that I wasn't able to get these printed out. For tomorrow's class, I'll get some printed out ones. Donated by the art by.
Mr. T, did you submit a materials request for it?
No, I did not.
Oh, okay, I would've just felt
No.
bad if you did and they didn't.
No.
Okay,
that
no
was my
problem.
fault. I mean, I have like some. Actually, I do have some. Printed out ones. I have these.
It's okay, I would just have hated if you did and
Yeah,
had
no.
screened at a bunch of volunteers. Okay.
That's all. Forget it. Alright. Let's just do a short one.
Oh my God, that's a carrot.
Alright, here's one. So Isaiah used his savings
Using his savings.
Do you want to start this now?
yeah, this is a short one. To buy a $531.25 laptop. Laptop.
That's gonna be a book. That's gonna be a game laptop.
How much
That's exactly what I'm buying.
That's another big problem. You used 5/8, okay, of your savings to buy a $531 laptop. How much did he have saved before he bought the laptop?
You should 8 what?
5/8
Oh.
5/8.
before he bought the laptop.
Before he bought
Bought
the
the
laptop. Yeah. Use 5/8, okay? So Isaiah used 5/8 of his savings to buy a $531.25 laptop. How much did he have saved before he bought the laptop? So what I'm gonna demonstrate before I start giving you some practice problems is how to approach a word problem, right? How to recognize, or not how to, but what are the recognizable words? Like what are the most important words in a word problem, right? And I'm gonna show you how to formulate a linear equation so you can then solve for the variable, okay? So, since this is Isaiah's problem, right? Isaiah, what's your favorite color?
Go with red.
So Isaiah used 5/8, okay? So that's an important number of his savings, and the fact that he used them, okay? To buy a $531 laptop, and 25-cent laptop, can't forget 25 cents. So how much did he have saved before he bought the laptop, right? So some of the important words here. So we know that you use 5/8 of your savings. And we know that 5/8 of your savings is equivalent to $531.25. Why? How do we know that? Because the problem tells us that you used 5/8 of your savings to buy the laptop. Okay? Okay. Give me a second, I'm gonna show you. So, how much did he have saved before he bought the laptop? So what are we looking for? We're looking for
How much?
the grand total before you bought the laptop, right? Okay. So, we know that you use 5/8. Okay? We know you use 5/8 of your total savings, okay? Let's call, what do we want to call total savings?
S.
Want to call them S? So 5/8 S, right? We know that this right here is equivalent to what?
531.
531.
25 cents.
Exactly. Alright, we don't need that. Okay?
Yeah.
So now, does somebody want to like break down what this linear equation means to me? Like what does it mean in relation to the problem? Like just one more time, like reiterate it.
If we,
Because you all know it, you guys just literally told me, so I just want someone to, huh?
how much you saved before you bought the laptop? The total savings?
So, this is how much he spent. Everybody understand that? 5/8 S is equivalent to how much he spent because the problem tells us that's 5/8 of the savings, right? We're looking for S because what does S represent?
Oh, total.
The total amount of savings, okay? So here, we have a linear equation, right? And we have a one-step linear equation. So, what would be the next step, Jakai?
Divide
What about what?
by 8.
Okay, if I do it on this side, and then what?
That's all. We'll do it on the
Glad you guys like this one. Alright, so this will cancel, right?
Yes.
Imaginary 1. So then we go outside, stays on the outside, inside, outside, inside rule. What's on top stays on top, okay? So S is equivalent to 531.25 times 8 divided by 5. Okay? That's obviously not the answer in the simplest of forms, but I'm assuming you all know how to multiply, all of that stuff, so remember, it's not about the number being perfect, it's just about getting this answer. If I ever ask you to simplify, you guys know how to simplify, so there you go. Does everybody understand that? Okay, so I'm gonna give you guys a separate word problem. We'll first take down the notes. I'll just calculate this.
If they have calculators as 8th graders, they can use them.
Yeah,
Yeah.
that's 850. I always thought that they weren't supposed to have calculators.
As 8th graders, they,
Like,
yeah, especially if it's numbered like this.
Yeah.
I mean, I'm saying if they have calculators in the library, you can totally have them available for them. to use. Yeah. As long as they're showing that they're setting it up properly, they don't.
Yeah, that's really what I care about. Like,
Cause I know that something like that will take forever for them to have to solve. And they're given calculators on their assessments and in class.
you got a genius upon us. Alright.
Were they able to do it?
So, everybody got that?
Yeah.
I don't know.
Alright, so here's another word problem, okay? So, the sum of let's just do three consecutive numbers is 48. What is the smallest of these numbers? So I'm going to leave you guys to solve this, but before I do, I'm going to ask you guys a few questions. So what's the sum? Just to review. So it's the answer to an addition problem, right? What does the word consecutive mean? Everyone know?
Back to back.
Isaiah, you want to say that a little bit louder?
Back to back, I guess, like.
So can you give me an example of some consecutive numbers? 1, 2, 3. Those are 3 consecutive numbers. Right? So the sum of 3 consecutive numbers, so the sum of 3 numbers that follow like 1, 2, 3 that are one right after the other, correct? Equal 48. The number 48. So what is the smallest of these 3 consecutive numbers? So you
find the 3 consecutive numbers
So you have to, the answer to the question is whatever that smallest number is. But what I don't want you guys to do is to start writing down numbers like, and start testing out which is the answer. Because I don't really care what the answer is. To be honest, I don't. Like, I don't care if you could tell me the number. What I care about is how you set up this problem. And are you properly setting up the problem in such a, are you setting up the problem in such a way that you can find the correct answer? That's what I care about the most. So when I'm walking around, I don't want to see just numbers. I want to see you guys attempting to find whatever it is that we're trying to find, the smallest number. Okay. So I'm going to give you guys another little tip. The first thing that you usually want to do is, in a word problem, is determine what it is that you're trying to find. Okay? So you're trying to find the smallest of these 3 consecutive numbers that equal up to, that add up to 48. And once you understand what it is that you have to find, you want to name it. So just how you said when I asked, oh, what do we want to call the savings? And you said S, just like that. That process right there is the first thing you have to do. And once you do that, you can tackle the problem. So I'm going to leave you guys out for a few minutes. I think the best way to start solving something that like you really haven't seen before like that is maybe just start writing down. You know, you can't really do this in your head. So just start writing down thoughts. You know, and once you start testing things out, once you start visualizing things, it sort of becomes a lot more intuitive. Whereas if you keep all that stuff in your head, you can't really work it out. So. I'll give you guys a little hint. So 3 consecutive numbers. So let's go back to our normal example, right? 1, 2, and 3. Right? What's the smallest of those 3 numbers? 1, right? So now think about what is 2 in relation to 1, and what is 3 in relation to 1. Okay? What if I asked the question, the sum of 3 consecutive numbers is 6. What is the smallest of these numbers? You guys would have all said 1, right? 1, 2, 3. Right? But I'm asking you to set up the equation. So if you were to set up an equation on how to find that, right? You're trying to find X, or S, or R, or J, or I, or A, whatever the variable is. You're trying to find the smallest number, right? In order to find that, you have to set that thing, that variable, up in such a way where it relates to the other components of the equation. Does everybody understand that? There are other pieces to the equation. There's 2 other numbers. What are those numbers? You have to relate them back to X. So what's 2 to 1? It's 1 plus 1, right? What's 3 to 1? 1 plus 2. So think about that idea and how you could form an equation for how to solve this. let's stop. I'm gonna walk you guys through this problem, okay? Chicago, what's your favorite color? Green. Darker green. Alright, so the sum of 3 consecutive numbers is 48. What is the smallest of these numbers? Okay, so let's really break down this problem. The sum. First important word that we see. What's a sum?
The product of an addition.
What? Let's raise your hands. Somebody want to raise their hands?
The
No?
value to addition.
Yeah, so the answer to an addition problem. So the sum. So that already tells us right now there's gonna be some sort of addition going on, right? Of 3 consecutive numbers. So of 3 consecutive numbers. Okay? So we know that there are 3 numbers, there are 3 values that are being added up, right? And those 3 values, when added up, equal 48. Okay? So the question is now asking, what is the smallest? Not the biggest, not the one in the middle, what's the smallest of these numbers? Right? So, let's read over it one more time, and let's do the problem as we read it now. So the sum of 3 consecutive numbers is 48. So I know that 48 is equal to 3 numbers, right? I'm not going to write down X, Y, and Z yet because I want to finish reading the problem. So what is the smallest of these numbers? Okay, so now I know what I'm looking for. I know that there are 3 values, and I know that of those 3 values, I need to find the smallest of them. They need to be consecutive, and when they add up, they equal 48. Okay, so what do we want to call the smallest of these numbers?
J.
J? Let's call it J, right? So let J, we could even write down like a little key down here. Let J equal smallest of these numbers. Smallest number, right? Smallest of the numbers, right? So 48 equals J. So now I know that J is what I'm looking for, and it is being added by whatever comes after J, and whatever comes 2 after J, right? Because it's 3 consecutive numbers. So what is the number after J? We know it. And we don't know the exact value, but we know how to denote it. So remember when I told you, think about like what's 2 in reference to 1? What's 3 in reference to 1? Any ideas of this happening? No? So let's say J is 6. What would be the number after 6? Right? How else could you rewrite 7 in reference to 6? Right? Say it louder. 6 plus 1, right? So what's the number after J? No. Not like the alphabet. So what's the number after J? What? You just said the, what's up? It's not 6 plus 1. The number, so if I'm asking, let's suppose, pretend that J is 6, just for me to get this information across, so pretend that J is 6, and I'm asking you, what's, like, so 6 plus 1 is 7, right? How would you write 7 in relation to 6? Okay? Now, forget the number 6. Now, think about the letter J. Okay? What's the number that would follow right after J that's consecutive on the timeline? So we have a timeline, not a timeline, a number line, right? Okay? We have 7. This is 8. This is 9, right?
J plus 1.
It's J plus 1. Can you say that a little bit louder, Chica?
J plus 1.
Okay, do you wanna? So why is that the case? consecutive whole number? What's the third consecutive number in relation to j? So if I have j, then the number after it is j plus 1,
J plus 2.
j plus 2. Okay? You all understand that?
Yeah.
No? Rihanna, do you understand that?
I'm trying to get it now. A little bit.
First J equals 6, then J plus 1 equals 7, then J plus 2. Okay, yeah.
You understand? Like that's for the example, that's not the actual answer. That was just for me to give you guys something.
Yes.
Okay? Okay? So now what? We've already set up the equation, right?
Yeah.
These parentheses, they don't mean anything, right? Because we're just adding expressions, doesn't matter. So it's gonna be j plus 1 plus j plus 2, right? So what is this equal to? 48 equals, so we have 3 j's.
3.
So what is that? What is j plus j equivalent to?
3J.
So 3j.
3J.
Good job, Rihanna. Alright. Now what else? Now, this looks like a linear equation that we've dealt with several times before, right?
Yeah.
So now, what is the first step that we have to take? What's the first question we have to ask?
Isolate the J.
Isolate the j, right? How do we do that?
Subtract 3 on both sides.
Subtract 3 on both sides. Exactly. So 48 minus 3 is
45.
equal to 3j.
Yes. 15. J equals 15.
So now we're dividing both sides by 3, correct?
Yes.
And j is equal to 15. Alright guys,
Yes.
we're gonna do more word problems tomorrow. Yeah, just be sure to write this down. I'm gonna give you guys another problem similar to this one tomorrow. John, did you write this down?
Yeah.
Okay. I'm gonna ask you to show me your notes tomorrow.
Okay.
Okay, I hope it's okay.
I'm listening.
Procedure.